Hi, Assalamualaikum and good day everyone. For this video, we will enter chapter 2 thermochemistry, and for this subtopic, the first one is concept of enthalpy. At the end of this lesson, you should be able to explain endothermic and exothermic reaction by using energy profile diagram, state the standard condition, and define enthalpy and standard enthalpy. So there are a few definition of enthalpies that you need to know, and you need to know the definition of each of these. Then only you can write the thermochemical equation. Okay. So for thermochemistry, it is the study of energy changes that which take place during a chemical reaction. So anything thermo means it is related to heat. So all your chemical reaction, it must be either absorbing or releasing energy in form of heat. When a reaction takes place, okay, the heat content of your system will change. And the heat content of your system, itu yang kita panggil sebagai enthalpy. So nanti I'll explain to you what is system and what is surrounding. So for enthalpy, it is defined, enthalpy is simbol H ni saja. It is defined as your heat content of your system ataupun your total energy of your in the system. Okay, it is measured by unit joule ataupun kilojoule, okay, ataupun J saja, joule, unit joule. And then the total enthalpy of your reaction, you cannot measure it directly. Macam contoh, you can't put into a device ataupun anything yang boleh terus directly measure the enthalpy of the reaction. Okay, but you will use this formula. Okay, nanti Miss akan tunjuk formula. You will need to calculate this change in the enthalpy. So ataupun delta H lah, changes in enthalpy. So the change in enthalpy, or in other words, kita panggil dia sebagai heat of your reaction. Okay, so enthalpy of reaction, delta H ni is the difference. Okay, different. Delta H is hasil tolak enthalpy of your product minus enthalpy of your reactant. That is why kita note dia sebagai delta H. Okay, change in enthalpy. So product tolak reactant. And the technique that we use to measure this delta H is called as calorimetry. Kalau alatnya kita panggil sebagai calorimeter. There are two types of reaction that you need to know, and you already familiar with these two terms. First is exothermic, and then the second one is endothermic reaction. So endothermic reaction and exothermic reaction ni, okay, so for this one it is release, keyword dia, and this one endo, absorb. Okay, so release apa, absorb apa, kita akan tengok. Okay, so this is your summary. Exothermic versus endothermic reaction. So exothermic is a reaction that release heat to the surrounding. So apa tu surrounding, apa tu system? Okay, so have a look here. So imagine this yellow box ini adalah your system, and then this blue color is your surrounding. Okay, so let's say if your reaction happen in here, okay, and it is exothermic reaction. So bila exothermic reaction berlaku dalam this container, Okay, you will release heat in form of you will release energy in form of heat to the surrounding. So maksudnya dari dalam sistem dia akan release heat pergi your surrounding. Okay, yang biru ni. Okay, dia akan bebaskan heat. But for endothermic reaction, okay, so endothermic reaction is reaction that absorb heat from the surrounding. So bila dia absorb heat, heat tu datang daripada surrounding. It is absorbed to this system. Okay, that is why you can see the differences in temperature. So kalau untuk exothermic reaction, temperature will increase lah. Okay, sebab kita measure temperature of your surrounding. Okay. So for endothermic reaction tadi, kalau kita nak measure the temperature, okay, kita akan measure the temperature of your surroundings ini. Okay, this your surrounding. So that is why we can see ataupun we can observe temperature akan decrease for endothermic reaction. Okay, tapi what if your reaction is exothermic reaction? So bila exothermic reaction, heat is released daripada sistem, dia akan bebaskan heat to the surrounding. That is why we can observe, okay, bila kamu letak thermometer, kamu akan tengok bacaan suhu, temperature will increase, because the keyword here is we are measuring the temperature of your surrounding. So get that clear. Okay, this two is your energy profile diagram. So lepas ni jangan lagi tanya apa tu energy profile diagram. This is your energy profile diagram. And untuk exothermic reaction, you can see reactant is higher than product. Okay, nanti Miss akan explain in detail. For your endothermic reaction, reactant bahagian bawah ni, product is higher. Okay, and remember keyword dia penting yang kamu kena ingat. Kalau exothermic, delta H negatif. Kalau endothermic, delta H nya positif. Okay, so for exothermic reaction, okay, ini adalah your exothermic. Okay, macam mana tahu? Because you can see reactant is higher compared to your product. Okay, kenapa Miss cakap macam tu? Because when you masukkan value, okay, let's say sini value-nya 10 and here 3. So bila kamu masukkan this to find delta H for this reaction, okay, so kamu akan masukkan enthalpy of your product 3 tolak 10 enthalpy of your reactant. Okay, so kamu akan dapat negative 7. So from here, from your energy profile diagram, you can see bila dia negative, it is an exothermic reaction, means heat is being released from the system to the surrounding. Okay, macam yang tadi I've explained to you, temperature akan increase, temperature of surrounding. Okay, so this explain why delta H is negative, because the heat content of your product, okay, product here is lower compared to the heat content for your reactant. Okay, so for your endothermic reaction, okay, ini adalah endothermic. So why this is an endothermic reaction? as I mentioned to you before, okay, bila kita nak cari delta H, so your delta H, okay, kiraannya enthalpy of your product minus enthalpy of your reactant. Okay, so imagine dekat sini value-nya 3 and here the value is 10. Okay, so product tolak reactant, product 10 enthalpinya, and then reactant 3. So 10 tolak 3, kamu akan dapat 7, positif 7, right? So bila bila delta H is positive, means you will have an endothermic reaction. Maksudnya heat is being absorbed from the surrounding. Okay, so macam yang tadi Miss tunjuk. So ini your system. So outside here is your surrounding. So heat is being absorbed from your surrounding masuk ke dalam sistem. That is why bila kita ukur suhu dekat sini, let's say you put your thermometer, temperature of your surrounding outside here, okay, yang di bahagian luar ni, temperature outside here akan decrease. Okay, right, so that is why kamu dapat delta H nya positive because of the heat content of your product here is higher than your heat content of your reactant. Okay, right, so look at your example. Okay, let's say example 1, you have this reaction and you are given delta H nya ini. So from your delta H, changes in enthalpy negative 112 kilojoule per mole. So for this reaction, we know that it is an exothermic. Okay, that is why kamu punya reactant. Okay, so ini bahagian reactant, ini produk. Reactant lebih tinggi daripada produk. So kamu mesti tulis, if you know the reaction, okay, mesti tulislah dia punya this side, zinc solid tambah lead 2 nitrate aqueous. Okay, mesti label, not just reactant and product like that. Okay, so the product here must be NO3 plus PB in solid, and then as you can see here, kamu ada diberi value of delta H. So sini akan jadi negative 122 kilojoule per mole. Okay, so all your labeling dalam energy profile diagram must be complete like this, baru kamu dapat markah. And try for your other example, sama juga. Yang penting you need to identify first. Okay, look at the reaction, determine whether it is endo ataupun exothermic, and then draw the energy profile diagram with correct labeling, and tulis reactant, tulis product, and write the delta H punya value from the given value here. Okay, right, so now what is standard enthalpy of a reaction? Okay, so standard enthalpy ni pula, okay, you can see delta H kita dah tahu. Okay, standard enthalpy, so kalau kamu nampak perkataan standard, okay, it means that the enthalpy changes happen at standard condition. So, apa tu standard condition? Means it must be at 25 degree ataupun 298 Kelvin. Pressure must be at 1 atm. and the solution concentration must be 1 molar. Okay, and biasanya kalau kamu nampak bulat kecil di bahagian sini macam simbol degree tu, okay, it means that it happened at standard condition. Okay, so under this condition, the reactant and product are said to be in their standard state. Okay, right, so there are few enthalpies that you need to memorize all the definition, and from there, bila kamu tahu the definition of each enthalpy, okay, setiap satu patah definition tu kamu kena hafal, and when you memorize ataupun faham dia punya definition, barulah kamu boleh tulis dia punya thermochemical equation. Okay, so kita akan tengok one by one. Formation, okay, so kalau kamu tengok dekat sini, kalau F kecil maksudnya enthalpy of formation, kalau ada C, combustion, A, atomization, neutralization, hydration. Okay, so kita akan just guna this symbol lah. Okay, EA, electron affinity, LE, lattice energy, LDE, lattice dissociation energy. Okay, so kita akan tengok one by one definition and how to write the thermochemical equation. Okay, kita akan tengok the first enthalpy, which is standard enthalpy of formation. Okay, so cara tulis this enthalpy is delta H. Okay, kalau dia cakap at standard condition, mesti lukis this small bulat here and F untuk formation. Okay, macam ni lah. And the definition is heat change. Okay, so dia ada banyak definition. Ada 3. Heat change, heat release, heat absorb. So kalau dekat sini dia tulis heat change, maksudnya apa? Dia boleh delta H kamu boleh jadi negatif ataupun positif. Okay, ada certain reaction dia akan release heat, ada certain reaction dia akan absorb heat. Okay, right. Okay, it is heat change when 1 mole of your compound is formed. Okay, kena faham betul-betul. 1 mole of your compound is formed maksudnya produk tu mesti 1 mole from its most stable elements under standard condition. Okay, under standard condition ni maksudnya kena tulis lah. If it is at standard condition. Okay, okay, tu untuk highlightkan the standard punya condition. Okay, mesti tulis this part. Okay, so back to this, the one I highlighted in yellow. Okay, 1 mole of your product is ataupun compound is formed. Okay, so when you see form, maksudnya dia adalah dalam produk lah. From its stable elements, so maksudnya daripada stable elements. Okay, ini your reactant must be the stable elements. Okay, contoh. Okay, formation of water. So kita boleh tengok your water. Okay, so I ajar you cara tulis. When you want to form water, okay, standard enthalpy formation of water, dia mesti sini, dekat sini mesti 1 mole. Okay, so 1 mole of your product ataupun compound form from its element. Okay, so kita tengok ada elemen apa? Hydrogen dan oksigen, stable elements. So hydrogen stable state dia adalah H2 gas. Okay, and O, oksigen, Dia exist stable as O2 gas. Okay. So, bila kita dah dapat equation ini, kita kena balancekan this equation. Okay. Boleh tak kalau dekat sini, I put it 2. And then here, okay. So, I balance this equation like this. Okay. Is it balanced? Okay. So, for this case, kalau kamu nak tulis standard enthalpy of formation of water, you can't balance it like this. Okay. Dia mestilah, siapa tadi 1 mole? As you mentioned here, dia mestilah 1 mole of your compound form. Okay. So, sini wajib 1 mole. Kamu tak boleh kacau. So, when here you must get 1 mole. So, yang lain-lain bahagian reactant tu yang kamu balancekan. So, in this case, ini akan jadi 1/2. Okay, itu cara untuk balancekan equation. Yang penting, kamu tengok. First, tengok heat. Okay, untuk definition, heat change atau absorb atau release. And then the second thing you need to tengok dalam definition. So, siapa yang 1 mole? Okay. Bahagian produk ke bahagian reactant? Okay. Alright. So, untuk C2H4 in gas, okay. So, enthalpy formation of C2H4, dia mesti from its element, most stable state of its element. So, kamu ada kat sini carbon, then you have hydrogen. Okay, so carbon exists as solid, stable state. Maksudnya dalam keadaan biasa, dia exist sebagai carbon in form of solid, and your hydrogen H2 in form of gas. Okay, so make sure your product here is 1 mole, and then when you want to balance the equation, okay, sini akan jadi 2. So, sini akan jadi 2. So, this is your equation, and then tulis delta H formation berapa. Okay. Okay, so for your reaction or formation of C2H4, this is your enthalpy. Okay. And, okay. So, the standard enthalpy formation of any element in its most stable state is 0. Okay, maksudnya apa? So, you can see kalau contoh formation of oxygen. So, kalau formation of oxygen, O2, dia, as you can see from the definition, 1 mole of your oxygen is formed from its stable state. So, dia mesti daripada O2 in gas juga. Okay. So, kalau in this case, dia punya enthalpy is 0 lah, sebab it come from its stable state. Sama juga macam Cl2. Stable state-nya adalah Cl2 in gas. So, delta H-nya adalah 0. Alright, so now let's have a look at standard enthalpy of combustion. Okay, delta H. Okay, kalau standard ada bulat kecil ni, degree. And your C for combustion. Right? So, definition dekat sini, tengok. Look carefully, it is heat release. So, maksudnya apa? All combustion, okay, dia akan delta H negative for all reaction yang melibatkan combustion. Okay? And look at the definition. When 1 mole of your substance is burned completely in excess oxygen. So, maksudnya apa? Compound kamu tu dalam reactant. Substance ni adalah your reactant. Okay, under standard condition. Okay, under standard condition ni macam sama je lah. Untuk all standard condition 25 degrees Celsius and 1 atm ni kena tulis lah kalau dia minta definition. Okay, alright. So for example yang ada dalam write this example in your notes. Okay, so let's say you need to write the thermochemical equation for combustion of carbon. Okay, so combustion of carbon. So your carbon in solid. Okay, siapa yang kena 1 mol? Okay, nanti I'll write it. 1 mole of your substance. Okay, your substance here is carbon, mesti 1 mole. Okay, it is burned in excess oxygen. So kalau excess oxygen tu maksudnya mole untuk oxygen can be varies. Okay, dia tak tetap lah. Right, so you will get CO2 gas. Okay, so this is the thermochemical equation for combustion of carbon. Okay, delta HC untuk delta HC for carbon. Okay, this is your equation, and when you write the delta H, okay, tulislah it should be negative sebab semuanya adalah negative ataupun heat is being released for all the reaction untuk combustion. Okay, so this is the thermochemical equation. So bila thermochemical equation, one more thing that you need to remember, mesti tulis equation penuh, balance, tulis dia punya state. Okay, state dia solid, liquid ke gas ke, okay, mesti tulis. And balance, tulis dia punya state, balance the equation, and then make sure siapa yang 1 mole tu keep them as 1 mole. Okay, based on the definition, and write dia punya value for delta H. Okay, macam ni lah, lengkap dari kiri ke kanan sini, lengkap, barulah dapat 1 mark. Right, so let's say you want to write the thermochemical equation for the next one, C2H5OH. Okay, so untuk this one, okay, siapa yang 1 mole, as I mentioned before, 1 mole of your sini compound yang kamu burn tu, ini yang 1 mole. Okay, so jangan kacau dia punya stoichiometry untuk your compound. Okay, and in excess oxygen maksudnya you can change the stoichiometry of your oxygen untuk balancekan the equation, and untuk combustion of your organic compound you will get CO2 and H2O. Okay, so bila kamu tulis equation, okay, so C2H5OH, okay, so 1 mole of your compound burn in excess oxygen akan dapat CO2 plus H2O. Okay, so produknya kita tahu. Kalau combustion, kalau ada nampak je hidrogen, maksudnya mesti akan form water. Okay, hidrogen dengan oxygen. Okay, kalau tak ada, dia akan remain stop sampai sini lah, CO2, sorry. And then bila kamu dah ada this equation, barulah kamu balancekan the equation, but keep here as 1 mole. Okay, so yang lain-lain kamu akan balancekan. C ada 2, and then hydrogen 1, 5, 6. So sini ada 3, and then here 3. Okay, so now you have your balance equation. Write the delta H punya value, and mesti negative because heat release here. Alright, so now kita tengok standard enthalpy of atomization. So, apa pula definition for atomization? Okay, ini heat absorb. So, maksudnya kalau heat absorb, it is delta H kamu mesti positif. Okay, when 1 mole, okay, so tengok siapa yang 1 mole. 1 mole of your gaseous atom is formed from its most stable element under standard condition. Okay, so you can see sebab the heat is absorbed, delta H atomization, enthalpy of atomization is always positive. Okay, sebab it involve breaking of bonds. So, untuk break bonds, kita akan perlu absorb heat. So, example untuk thermochemical equation. Okay, so contoh 1 mole of gaseous atom is formed. Okay, so contoh kita nak form sodium gas. Okay, 1 mole of your gaseous atom. So, sini kena 1 mole of your gaseous atom. Dia akan form from daripada its stable state. So, untuk sodium, stable state dia adalah dalam keadaan solid. So, delta H ni akan jadi positive something lah. Kamu akan ada value-nya. Okay, so contoh kalau kita nak form chlorine gas pula. Okay, so chlorine gas, okay, since dia atom, tengok atom. So, dia mesti dalam keadaan chlorine atom gas. Okay, 1 mole of your gaseous atom. So, sini kena 1 mole, 1 mole. And then here, stable state of your chlorine. Stable state dia biasanya akan exist sebagai Cl2. And biasanya dia akan exist sebagai gas. So, macam mana kita nak balancekan equation sini? Okay, kita tak boleh kacau here. Sebab from the definition, mesti 1 mole of your gaseous atom. Okay, so sini akan jadi 1/2. So, your delta H here will be positive. So, it involve for breaking bond. Okay, so sebab tu delta H nya always positive. Okay, so ini adalah contoh equation, thermochemical equation untuk standard enthalpy of atomization. Okay, next is standard enthalpy of neutralization. Okay, the next one is standard enthalpy for neutralization. The definition here, you can see heat release when 1 mole of water is formed from the neutralization of acid and base under standard condition. So, if you notice from your experiment titration last semester, okay, when you react acid dengan base, okay, some of you ada yang notice and ask me why the chemicals dalam the punya conical flask is panas. Okay, so di sini apa yang berlaku when you react acid and base, heat is being released. So, kalau heat release, okay, as I mentioned before, so ini kamu punya system, ini kamu punya surrounding. So, bila your reaction happen in your system, okay, and then heat release to the surrounding. So, temperature of surrounding increase. Okay, so that is why bila kamu pegang conical flask, kamu rasa dia panas. Okay, sedikit warm because of heat is being released when you react acid and base. Okay, when you want to write the thermochemical equation untuk enthalpy of neutralization, dia mesti 1 mole of your 1 mole of water. Okay, and your salt. And then contoh kamu ada NaOH, 1 mole of your NaOH, tambah NaOH, HCl. Okay, kamu akan dapat salt, NaCl in aqueous. Okay, when you want to balance the equation, make sure yang penting siapa yang 1 mole dekat sini? Your water molecule. So tak kisahlah acid kamu macam mana pun, acid and base punya reaction, your neutralization, yang penting untuk standard enthalpy of neutralization mesti 1 mole of water form. Okay, dekat bahagian water ni mesti 1 mole. Yang lain-lain ni boleh kita ubah dia punya stoichiometry. Okay, so ini dia punya contoh macam mana kamu tulis the thermochemical equation with value untuk delta H, enthalpy of neutralization lah, and mesti heat release negative. Semua untuk neutralization semuanya adalah heat release negative. Okay, next is standard enthalpy of hydration. So, untuk this one, heat release when 1 mole of your gaseous ion is hydrated in water. So, maksudnya 1 mole of your gases, okay, and then dia akan jadi aqueous. So, contohnya Na plus gaseous ion kan. So, sodium ion in gas hydrated tambah air, kamu akan dapat Na plus aqueous. Okay, so for this one dia adalah heat release. Okay, so siapa yang 1 mole mesti 1 mole of your gaseous ion di sini yang mesti 1 mole. Okay, so this is your example, and another example, let's say you have chlorine gas in ion and then hydrated in water. Kamu akan form Cl minus ion in aqueous. Okay, and the enthalpy is in negative, delta H negative. Okay, so for electron affinity, it is heat change when 1 mole of gaseous atom gain 1 mole of electron. So, tengok dia punya equation contoh. The first one, ini adalah the first electron affinity. So, dekat sini, 1 mole of your gaseous atom gain 1 mole of electron to form 1 mole of gaseous ion. So, ini adalah your first electron affinity. Okay, and untuk the first EA, dia adalah negative heat release. So, untuk second electron affinity here, okay, the value here is positive. So, kita tengok dia punya equation. So, dia datang daripada the first one. You can see O minus in gas. Okay, O minus in gas, 1 mole juga, gain another electron to form O2 minus ion in gas. Okay, the delta, the enthalpy ataupun value untuk second electron affinity adalah positive. Why it is always positive? Because the energy is being absorbed by the electron. Okay, this is to overcome the repulsion forces between the electron and negatively charged ion. So, biasanya dia melibatkan formation of negatively charged ion lah. Okay, electron affinity. Alright, so next one is lattice energy. So, untuk lattice energy, the energy release when 1 mole of your solid ionic compound is formed from its gaseous ion. So, siapa yang form? Energy release delta negative, delta H negative. So, siapa yang 1 mole? Your NaCl ni mesti 1 mole. Okay, from its gaseous ion. So, macam mana nak tulis? Contoh this one. Okay, let's say you have NaCl solid. Okay, mesti sini 1 mol from it gaseous ion. So ada Na dan Cl. So both must be in its ion. Okay, so macam tu je cara kamu nak tulis. That is why I mentioned to you the definition is very important for this chapter 2. Okay, so untuk lattice dissociation energy pula, dia adalah reverse. Okay, so you can see here negatif kepada delta H lattice. Dia adalah reverse. So kalau dekat sini kita baca gaseous ion Na plus tambah Cl minus dapat NaCl negatif 771. So for lattice dissociation energy, okay, it is the energy required to completely dissociate ataupun separate 1 mole of your solid ionic compound into its gaseous ion. So maksudnya apa? Daripada 1 mole of your 1 mole of your NaCl in dissociate to form Na plus gas plus Cl minus ion gas. Okay, so delta H kamu akan reverse kepada this value, so which is positive 771 kilojoule per mole. Okay, so you can see kalau per mole semua ni mesti 1 mole based on the definition. Okay, right, so next one is first IE and second IE. So these two kamu dah pun familiar, but remember the definition mesti kamu tulis lengkap. Minimum energy required to remove 1 mole of valence electron, 1 mole of electron from 1 mole of So it is to remove 1 mole of valence electron just now from 1 mole of neutral gaseous atom, okay, and to form 1 mole of your singly positive gaseous ion. So basically, if you have okay, so contoh Mg lah, Mg in gas, okay, remove 1 mole of electron, so you remove 1 electron, so mesti electron tu bahagian produk. Okay, so kalau absorb ataupun gain, electron di bahagian reactant. Okay, so in this case, electron in the product punya side. Remove 1 mole of valence electron from 1 mole of its neutral gaseous atom. Okay, ini to form singly positive ion. Okay, so the next one is second IE. So untuk second IE pula, it is energy required to remove 1 mole of electron. Masih lagi removing electron. Kalau electron affinity tadi, if you realize, dia adalah gain electron. So kalau IE remove electron. So maksudnya daripada gas atom, okay, you remove electron, 1 electron, and you will form positively charged gases ion. Okay, right, so for the second IE, okay, daripada sini, okay, kita dah ada dia punya Mg plus ion tadi. So Mg plus ion, gaseous ion, kita remove lagi 1 electron. to form from 1 mole of singly positive ion, okay, yang ini, to form 1 mole of positive 2 gaseous ion. So dia akan jadi Mg2 plus gaseous ion. Okay, so both of them adalah energy absorbed delta H must be positive. So, if the thermochemical equation is multiplied by a certain factor, then your delta H must be multiplied with the same factor. So, contoh, if you have your thermochemical equation untuk this one,